Hello friends, welcome to Weathercast. My next educational video is on mesoscale and submeso-scale systems and their influence on weather. This time what I'm going to do is I'm going to start with a small preview video which is just going to give you a gist of what is expected in this video, and this will be followed by a full module which I'll try to upload it by the weekend. We all know that the swirling motion of air and water gives us all we know, which is the weather dynamics, right? And these swirling motions actually give rise to a lot of scales of systems, which we already know that they exist on spatial scale as well as temporal scales. So if you look at this particular graph, it is trying to at least focus on the important systems that are seen in atmosphere and ocean. In a very brief manner, we can just demarcate these systems as submeso-scales and meso-scales. So submeso-scales are those which have spatial scales less than 10 kilometer, and meso-scales which have spatial scales greater than 10 kilometer. So if you look at the submeso-scale, then you have the small scale waves, the turbulent mixing, and then you also have these small eddies which tend to create a lot of mixing. And then if you look at the submeso-scale, you have Rossby waves, El Nino, and all those large scale phenomena. If you look at these global models, they are able to resolve the mesoscale processes. As you can see, these big vortices or these big eddies, right? So even if you look at this, the eddies, bigger eddies are there and smaller eddies are there, right? So the models are able to capture the bigger eddies, right? And also waves, right? Obviously you can see some wave patterns which will be captured by the models, but they are unable to capture the submesoscale processes because the submesoscale processes are small and the resolution is not enough to capture them. And these submeso-scale processes become very important because these are localized kind of mechanisms. For example, localized vortex formation, which are known to have a complex dynamics and give lot of rainfall and also have a very intense weather patterns. Thunderstorms are also one of them. So here I'm just showing you a typical vortex pattern where there's a low pressure which creates updraft, and then there is a high pressure. So you have a bigger cone followed by a smaller cone in the bottom. Funnel shaped structure, that is a typical vortex structure. So these vortices, small scale vortices, are known to give very intense systems, right? So hence it is important to understand how these mesoscale and submesoscale processes govern the weather. Okay, so that is the crux of this video. So this is just a preview. So in the full module, what I'm going to discuss is various types of mesoscale and submesoscale systems that are present in ocean and atmosphere. The importance of submeso-scale system, especially in governing weather dynamics, because we know that models cannot resolve them. I will also talk about mesoscale systems, but the focus will be on submeso-scale processes. And in the absence of high resolution model, how to predict these systems based on the dynamics and how to understand their impact on weather. All right. So I will upload the full module soon. So please stay tuned to my channel and subscribe. Thank you so much and have a good day.